going to be simplifying expressions. Lastly, we did the order of operations. Now we're moving on to the simplifying expressions. In the simplifying expression, pretty much the first rule, or we can see, is like commutative property. So commutative property is basically if you add two numbers, order doesn't matter. Let's a plus b is the same as the b plus a. In algebra, we say like a plus b is the same as the b plus a. Same thing, ab equals ba. What does that mean is, let's say if I take a 3 and 4. 3 plus 4, which is 7, and then 4 plus 3, it's also 7. So it doesn't matter, it's which order you add them. Same thing, 3 times 4, which is 12, and then 4 times 3, which is also 12. So it doesn't matter which order you do that. Okay, so that's for the addition multiplication. Okay, but again, it's a subtraction and then divide. It does matter, so you need to be careful with that. So, but that's called the commutative property. And the next one is associative property. Associative property is basically a plus b plus c is same as the a plus b plus c. What does that mean is, even you change your parentheses, you know whatever the order, and you still get the same results out of that. Okay. Now let's look into an example on this one. Using the commutative and then associative properties, simplify the following expression. So when you have a 4 times 9 times 25, so right now here you can use the commutative property. I mean, like, it really doesn't matter which order you multiply. As long as you multiply them correctly, you do get a correct answer. Let's say if I put this one 9 times 4 times 25. The reason behind I switched them because it helps me to multiply faster. So what I'm going to do now is 9 times I multiply 4 and 25. So what's 4 times 25?
4 times 25 is 100.
100, because like 4 quarters, like if you put it that together. So the 9 times 100 is 900. So obviously here we applied the commutative property, and then here we applied the associative property. So because we switched that, and then we just multiplied and we get the answer on that. The next really important concept is a distributive property. I want you to guys eyes on the screen really well, because this is you will see everywhere until like algebra 2 or calculus, whatever the math you take, you will see this distributive property is more often. So I want you to guys pay close attention, because it can get a little difficulty when you are basically looking deep into the algebra. You have a lot of variables involved, and you will get some more in depth with the distributive property. So what is the distributive property? It's very simple. And what it is basically is, let's say if you have any number outside or any letter outside, let's say 3 times 4 plus 8. And so what we're doing is basically we're multiplying with the 3, the outside number, the first inside number, and then also the second inside number, and then add them together. So if I do that one, 3 times 4, that is 12, plus 3 times 8, 24. If I combine them, that's going to be what, 36, right? And also the same thing in the last class, or in the last one, we looked into it, order of operations. If I follow that one, so which one should I do first?
You should do the parentheses.
That's right. So I should do the parentheses first. 4 plus 8 is 12, and then 3 times 12 is 36. So both of them get the same answer, but there is a benefit of using the distributive property. You will see more into the factoring those. You will see the distributive property a lot. So it's good to know it. We're going to do some examples. That way you can get a really good idea on this one.
Okay. Write each product using the distributive property, then simplify.
Okay. So if you look at this question, 15 times 103, it seems a little bit difficult, but what we can do, use the distributive property to make it easier. So what I can do this problem, 15, 103, I can write a 100 plus 3. Now I can distribute this one using the distributive property. So 15 times 100 that is easy, 1500, and then 15 times 3, that's 45. So you can say 50, 45. You see that? So that's the reason it's distributive property will help us to make some of the problems easier. Make sense? Okay.
Yeah.
All right. This time, go ahead and then use the distributive property and then solve these two questions, and then we'll check the answers. All right, Arya, tell me how did you do the first one? What did you do?
So first I took 52 and made it 50 plus 2.
Good job.
Then I multiplied 9 by 50 and then multiplied 9 by 2.
Okay.
And then I got 468.
Good work. Very good. Excellent.
I got the same thing.
Awesome. Sri, next one. How did you do this one?
So first I broke up 98 into 90 and 8.
That's right.
Yeah, and then I used the distributive property and multiplied 12 into 90, which would get 1080.
Okay.
And then I also multiplied 12 into 8, which would get me 98.
96.
And then I added both of 96, I mean. Then I would add both of them together, which would get me 1176.
Okay. So this is a good way. Arya, did you do the same way or do you do it a different way?
I did the different way.
Okay. What did you do?
Wait, I just did the same thing, like the 12, so I did 12 times 90 plus 8, and then I multiplied 12 by 9, 12 by 8, added them up.
Very good. Okay, so how about instead of 90 plus 8, can I write it, because 98 is pretty close to 100, I can write a 100 minus 2 also. You see that?
Yeah.
So if I multiply this one, 12 times 100 is like 1200, that's easy. And then 12 times 2 is 24. And then I can subtract it, I can get it 1176. Okay, so this one, there's nothing wrong in the both of them. You guys did it correctly. But if I look at it, the 100 minus 2 will be much faster because 12 times 100 is easy to multiply them. Does that make sense? So the distributive property is just not for the addition. You can also use it for the subtraction too.
Oh.
Because 100 minus 2 is also 98. So instead of 90 plus 8, you also can write 98 as 100 minus 2.
Oh, okay.
Then, because 12 times 100 is easier than 12 times 90. Know what I'm saying?
I mean, it still works either way, so.
Yeah, it works either way. It's nothing wrong if both of them are correctly. And but the thing is, like, we want to make it faster, easier. So, okay, good.
Okay.
So the next one is we are looking at called expressions. Expressions are contain like a letter, like terms, like terms, coefficients. So that's all combined together is called an expression. So we're going to talk about it. What is the term means? We're going to talk about it term means, and also constant, and also coefficient. And at the bottom, you can talk like terms. So this vocabulary is so important, and you will see some of the questions on the test too. So look at this expression 4x minus 3x plus 2. In this one, what is the term means? Okay, in this one, an expression, terms are separated by plus or minus. Separated by plus or minus. Okay, not the multiplication though. So, and terms means that's what it is. Okay, so they're separated by plus or minuses. And here I can say like 1, 2, 3 terms, but before that we can say we have to kind of like put it together. So the next one is constant. Constant is just a number. Number without a letter or variable. In this one, the 2 is a constant. Because 2 doesn't have any letter next to it. Okay? Good?
Mm-hmm. Good.
Okay. Like terms means with the same letter, with the same variable.
Yeah, I know that.
Okay. So what are the like terms in this one?
4x, x, and 3x.
And 3x.
No, x. Isn't it just x?
No, 4x and negative 3x are the like terms. Okay? Because they have the same letter or the variable, you can say it. Okay? And then if I put it together, that's let's say if I put it together, let's basically in a basket you have 4 oranges and you want to take away 3 oranges. So you're going to get a 1x plus 2. Okay, when I combine these two. In this one, coefficient means yeah.
Yeah, a coefficient is like, so if for like 4x, the coefficient would be 4, right?
Right. So in this case, this coefficient is 1. So the number in front of the letter. Okay. Number in front of the letter. Okay, so that's what coefficient means. Okay, does that make sense? Now look at this expression here. Tell me how many terms, and also if you have any like terms, tell me if are there any like terms. Are there any like terms? And what are the coefficients? Okay, so I'm going to give you a minute, find out all these, and we're going to check it. All right, tell me what are the terms in this one?
3x and 1x squared.
1x squared. How many terms? There, yeah, 2 terms.
Yep.
Okay. Are there any like terms?
Yeah.
What are they?
1x and 3x.
This is x, and this is x squared.
Yeah, x.
So x and x squared, they're not like terms. Okay?
Yeah.
So no like terms. If this is like 1x and 3x, yes, they're like terms. Or 1x squared and 3x squared, yes, they're like terms. But if even this power is not same, then they are not like terms. What about the coefficients?
The coefficients are 1 and 3.
1 and 3. That's it. Very good. Good job. The next one is combining like terms. These like terms are basically, just imagine that you have a basket of fruit. And in this one, you have some oranges. Let me put some color. Oranges. And then you have some apples. Okay? So apples together. So if you want me to put it together, let's say I'll put the apples together and oranges together. I say like oranges are 1, 2, 3, 4, 5 oranges. So let's say oranges are, let's put the letter orange. Oops, let me change the color. Orange is X, and then apple or Y. Okay, so if I put that way, then I can say it. How many oranges are there here? So 5 oranges up here, so it's a 5x for the oranges. Plus, we have 3 apples in this one, so 3y here. Okay, if I write an expression for that picture, this is how it comes. Okay, but when I have this one, I put it together. Like all the oranges, I put it together. All the apples, I put it together. Same thing. If I see the same letter here on the variable, then they are like terms. Then I can combine them. So all I need to do is 12 plus 30. And then keep that x. So 12 plus 30 is a 42x. Basically 12 oranges plus 30 oranges altogether is 42 oranges. Does that make sense?
Yeah.
Let's try this question. Look at this question and see if you have any like terms and combine like terms and tell me what is the final answer or simplified answer. Okay, try that. All right, let's see what like terms do we have here. So when I look at this question here, obviously 5x, 3x is also there, and also 9x. Okay, so these are like terms because I have the same letters or same variables. So when I combine them, I'm going to do this way. 5 and then minus 3 and then that's plus 9. Just put the x. But 3x squared, they're not like terms. This is just separate. I'm going to put that away. Now just do the math up here. 5 minus 3 is 2 plus 9 is 11x plus 3x squared. That's a simplified answer. Can we combine these two?
No,
No,
you cannot.
Because they're not like terms. Good work.
Mm.
So if you want to write it in the order, you can write it 3x squared plus 11x. That's it. You can't combine them because these are apples.
I got the same.
These are oranges. Good job. They can't combine them. That's it. That's the answer. Try number 42 and 43. Try these two. You guys can check that one. When I look at it here, let me use the highlighter. So 8x, 2x, minus 9x. These are like terms. So 8 plus 2 is 10, minus 9 is 1. That's good. 1x. You always need to write the 1.
Oh, I forgot the x.
Yeah, it's okay. And then minus 3y. I don't have anything out there, so it's minus 3y. That's good. And with this one here, the next one, so 7y, 6y, they're like terms. They're positive, so put them together. So that gives you 13y. And then, and the numbers, minus 3 and minus 7. So both of them are negative. Just we learned in the integers, when both of them are negatives, you just
wasn't that a sub?
Add them and put a negative. So that's what it is. Okay. And this it's even if it is kind of like if you do a mistake, it's okay. Don't feel bad because this is the time to learn it. So that's what it's all about, learning.
So wait.
The next one, we have a little combination of the distributive property because I see a number in front of the parenthesis, and then we need to kind of like combine the like terms. So there are two steps in this one. So the first one, apply the distributive property. I'm going to distribute these and this.
So it'll be 2x plus
12
plus 3x.
Plus 3x. So what I applied is distributive property. Okay. And then when I see this one, probably I can just rewrite them to make a sense. 12 plus 2x, just to write this one. You don't need to do all these. And this is kind of like a commutative property. Just to explain all the math behind. Then we can see combine these two like terms. That's 5x like terms. And you can write it again, 5x plus 12, commutative property. Okay. And I don't see any like terms, so that's my answer, final answer. Does that make sense? We're using the distributive property in there. Okay, good.
Okay.
So we're applying the same concept to the geometry. Okay, go ahead and try this one. So let's check this one quickly. So one way is basically it's a perimeter of a triangle, means you add all the sides. So then I can start it for p plus 3p plus 1 plus 8 minus p. Okay, now look for the like terms. When I look at the like terms with the letter p, I have these three of them. Okay, so when I put them together, so 4 plus 3, that's a 7, or I can write it 4 plus 3 and then minus 1 p. So that's the first thing. And the other one is the numbers. Constants, we can call this too, 1 and 8. So that gives me a 9. Okay, so if I do this one, 4 plus 3 is 7 minus 1 is a 6p plus 9. I don't see any like terms, that's the answer. But if this question comes in an SAT or something like that, this is what you need to do. So I see this like terms, 4p plus 3p and then minus 1p. So that gives me 4 plus 3 is 7 minus 1, that's a 6p. And then the other numbers, constants, I can say it. This is 1, and this is 8, plus 8. So that's plus 9. That's it. Okay? All right, let's look at a test prep question. Let's get some idea on this.
Should be like 50.
So you distribute that, it's completed, and then now combine the like terms. So combined like terms is x, this is another x, and this is another x. So total of them, it's 5x. Okay, and then combine the numbers. So the numbers are 19 plus 57. What's 19 plus 57?
76.
76. Okay, so that's the answer for that. Okay, so we're gonna do more practice on. Okay. We're gonna do more practice on distributive property, combining like terms, because that is really important one. So we're gonna do more questions, but today's concept is basically like simplifying expressions. We did the distributive property and using distributive property to simplify expressions. We looked into the like terms, coefficient, constant, and combining the distributive property and then combining like terms. And we did some geometry and test preparation questions. And we're going to do more practice on these topics. All right?
Okay.
That's good.